This question says 3 to the x minus 2 equals 81 to the x. So let's do some analysis here. 3 to the first equals 3. 3 to the second is 3 times 3, which is 9. 3 to the third is 3 times 3, 9 times 3, which is 27. And 3 to the fourth is 3 times 3, 9 times 3 is 27 times 3 is 81. So I can replace 81 with 3 to the fourth. So we have 3 to the x minus 2 equals 3 to the fourth raised to the x power. Now I just want to remind you of some basics with exponents. If I have x squared times x third, times x to the third, what does that mean? If I have x squared to the third, what does that mean? Just to remind ourselves of the basic rules of exponents. Well, x to the second means x times x. X to the third means x times x times x. So that's x to the fifth. And of course, 2 plus 3 is 5, which reminds us if the bases are the same and you're multiplying, add the exponents. But here, we're raising a power to a power, which is what we're doing here. X to the second to the third power means x to the second is written down 3 times. Which of course means xx, xx, xx. Putting all those together, we get x to the sixth. So you can see when you raise a power to a power, you multiply the exponents. When you multiply things with the same base, you add the exponents. But think about these examples so that you don't confuse those rules. So here we go next. We're going to take 3 to the x minus 2 equals 3 to the 4x. So if this is the case, then 3 to the something equals 3 to the something. The two somethings must be the same. X minus 2 must equal 4x. So let me go ahead and subtract 1x from both sides. And I get negative 2 is 4x minus 1x is 3x, and we'll divide by 3. And we get negative 2/3 is x. And let's see if I can check this. So what I have is I have 3 to the x minus 2 equals 81 to the x. And I'm going to rewrite that just slightly and say that's equivalent to saying 3 to the x minus 2 minus 81 to the x equals 0. And let's see if I can figure out what x has to be for that to be the case. And I think it should be negative 2/3. So I'm going to jump to the graphing calculator. And we're going to go 3 to the x minus 2. 3 to the, parentheses is probably what you want to use here, x minus 2. X minus 2 parentheses. Remember, we want it to be minus 81 to the x. Minus button is here. 81 to the x. We want to see when does that equal 0. We hope it's negative 2/3. Let me go to zoom decimal first. And let's see what that looks like. And you'll notice that it's really sitting very close to the x-axis. I believe it crosses somewhere there at negative 2/3. So I really have to adjust my window so I don't have much changing in terms of y. So negative 4.1 to 4.1 is much too big. How about negative 0.2 to 0.2? So we're really focusing in on the y values. I'm going to leave the x values alone, and I'm going to see, can I see where it crosses? Ah, it crosses there. Could you believe that that's negative 2/3? Well, let's use the 0 finder, second calc 0. Let's move the man in the spaceship a little bit to the left of the crisscross point, which is about there. A little bit to the right of the crisscross point, which is about there. Pretty close to the crisscross point. Hit enter. And negative 0.66667, which I hope you recognize, is indeed negative 2/3. So that reinforces what we had. Okay, I'm done with that. What's our next question going to be? 1/4 to the x equals 32. And what do we know about these numbers? Well, 2 to the first is 2. 2 to the second is 2 times 2, which is 4. So I can rewrite 1/4 as 1/2 to the second. So I have 1/2 to the second to the x equals, how about 32? Well, 2 to the third is 2 times 2 times 2, which is 8. 2 to the fourth is 2 times 2 times 2 times 2, which is 16. 2 to the fifth, 2 times 2 times 2 times 2 times 2, which is 32. So 32 is 2 to the fifth. Now what about 1/2 to the second? Well, that's the same as 2 to the negative second. That's what 2 to the negative second means, right? I mean, 2 to the negative k means 1/2 to the k. So 2 to the negative second means 1/2 to the second. So this thing is 2 to the negative 2 raised to the x power is 2 to the fifth power. So I've got a power raised to a power, and we saw earlier when that happens, we multiply the exponents. Here was our little example. X squared to the third power, x squared is x to the sixth. 2 times 3 is 6. So when you raise a power to a power, you multiply the exponents. So 2 to the negative 2 to the x is 2 to the negative 2x equals 2 to the fifth. So therefore, 2 to the something equals 2 to the something. The somethings must be equal. Negative 2x must equal 5. We divide by negative 2, and we get x is negative 5/2. But I want to also check this on the graphing calculator if I can. And you see our original question was this. 1/4 to the x equals 32. I want to subtract the 32 from both sides. I'm going to try to find x where 1/4 to the x minus 32 equals 0. And I hope I get negative 5/2, which is what? Negative 2.5. So just keep that in mind. So let's go back to the graphing calculator. And we want to show 1/4 to the x minus 32. 1/4 to the x minus 32, and I want that to equal 0. And I usually start with zoom decimal. I think it should cross at negative 5/2, negative 2.5. So zoom decimal is probably pretty good. So I hope it crosses at minus 2.5. Does it? Boy, it sure looks pretty good there, doesn't it? Maybe I can go straight to my zero finder. Second calc, 0. Move the man in the spaceship a little bit to the left of where it crosses. Can you see it? We're not seeing it yet. Oh, look at that, negative 2.5, 0. Well, unfortunately, we're not going to be able to zoom in on this. Left bound, a little bit to the left, negative 2.6. Right bound, negative 2.4. Guess. There, and there's my 0 at negative 2.5. If you want a better version of this, I'm going to add a little bit more y this time. So rather than negative 4 and 4, maybe I'll multiply them by 3, just so you can see it a little bit better. Let's take a look at our graph. So again, we think it crosses at negative 2.5. There we go. And I just want to go ahead and see where it crosses. Second calc, 0 finder. Move the man in the spaceship a little bit to the left of where it crosses. Hopefully we'll be able to see it on the screen this time. There we go, we can't see it on the screen, great. A little bit to the left, enter. A little bit to the right, enter, guess. And it gives me a 0 at negative 2.5, which is indeed negative 5/2. So that one checked. And I have one more question for me to do here, which works with this thing E. So here is my next question that I want to work on. E to the x squared equals e to the 3x times 1 over e squared. Now, what is e? What is e? E is a number like pi in that it is irrational. It's also something we call non-algebraic. It is about 2.718. 281828. That's how many decimal places the calculator will give you. It also is the limit as n goes to infinity of 1 plus 1 over n to the nth power. This number becomes very important in calculus. So if I use a large number, let's say 1,000,000, what is 1 plus 1 over 1,000,000 to the 1,000,000? It should be pretty close to this thing e. So let me go ahead and pull up the calculator to see how that's going to work. One plus 1 over 1,000,000. 1, 2, 3, 4, 5, 6. Raised to the 1,000,000 power. 1, 2, 3, 4, 5, 6. What do I get? A number pretty close to that 2.718 number that I had given you. So it's just one more number that you can work with. And again, it's terribly important in calculus. But how do we solve this? E to the x squared equals e to the 3x times 1 over e squared. I want you to remember, again, that x to the negative 5 means 1 over x to the 5th. Right? So 1 over e squared would be the same thing as e to the negative 2. So looking at our question here, 1 over e squared becomes e to the negative 2. We're going to rewrite this as e to the x squared equals e to the 3x times e to the negative 2. And remember, when we are multiplying things with the same base, we add the exponents. So I get e to the x squared equals e to the 3x plus e plus negative 2. You add the exponents. Okay. So of course, e to the x squared equals e to the 3x minus 2. E to the something equals e to the something. The two somethings have to be equal. So x squared equals 3x minus 2. And then how do we solve that? How are we going to solve x squared equals 3x minus 2? Well, we've got to get all of the x's on one side. That is a quadratic. So I'm going to subtract 3x from both sides. I'm going to add 2 to both sides. Subtract 3x, subtract 3x, add 2, add 2. So that the right-hand side just becomes 0, but the left-hand side becomes x squared minus 3x plus 2. Which you could solve with the quadratic formula. You could solve with completing the square, but I certainly think the simplest way to solve this is with factoring. So let's factor it. X squared here, plus 2 here, minus 3x here. X times x minus 2 times minus 1. Minus 2x minus 1x is minus 3x, so I get x minus 2x minus 1. So of course that means x minus 2 is 0 or x minus 1 is 0. So we get x is 2 or x is 1. Using the curly brace notation, we believe those are the two answers. Now, can we check this on the graphing calculator? It's going to be a little bit harder, but remember, this is what we're starting with. I would like to subtract the right side so that I get the thing equaling to 0. So what am I going to put into the graphing calculator? E to the x squared minus e to the 3x times 1 over e squared equals 0. And I hope I see answers that x equals 1 and x equals 2. So let's try it. e to the x squared. E to the is here. Second log, second ln. E to the x squared, I'm going to put that in parentheses just to make sure there's no issue with order of operations. E to the x squared, and I have to get down from there, minus e to the 3x, I'm going to put that in parentheses again, e to the second natural log, 3x, parentheses, times 1 over e squared, 1 over second 1 over e squared. I'm a little nervous about the order of operations here. Maybe we'll put an extra parentheses in there. 1 over e squared. Now I have no issues. Oops. So you can see that the computer syntax gets tricky here. But if you do it correctly, I hope my answers are going to be 1 and 2. So I'm going to go to zoom decimal first and see if it crosses at 1 and 2. What's it look like? Maybe it crosses at 1 and maybe it crosses at 2. I don't think I need to use my zero finder. I could just trace it along. There it is. X is 1, Y is 0. So 1 is a 0, 1 is a root, 1 is where it crosses the axis. So if X is 1, the result is 0. And similarly, similarly here. So indeed, 1 and 2 are our solutions. And that checks the work that we did by hand when we had our solutions are 1 and 2 for that equation.